Okay, thank you. Well, hello everyone, and thank you, Annie, for inviting me to your Telco to TechCo virtual event. It looks like I'm rounding out the event for everybody, and I'm just starting my day here. So my name is Simon Mason. I'm a solutions engineer at SS8. My focus at SS8 is on LBS platforms and LBS use cases. So today we're going to discuss the impact of emergency caller mandates on high accuracy location and how that impacts law enforcement. So our agenda, we'll just have a quick executive summary. Then we're going to talk about some of the EU regulation goals for emergency services around location accuracy. Then we're going to see how that impacts the emergency services LBS architecture. Then we're going to pull back out and talk about more GDPR exceptions for legal obligations and law enforcement directives, and then push back down into the emergency services architecture and how that can be extended to support law enforcement. And then we'll all round this out at the end with a whole tool chain that can be sit on top of the LBS architecture and provide tooling for law enforcement. So at the top, just kind of rounding everything out here, the EU has itself taken steps to improve emergency services locations by combining network-based and device-based positioning technologies. This was driven by the European Electronic Communication Code, which mandated accurate caller location information be provided to emergency services in a timely and reliable manner. That is the one of the objectives of the mandate. But then beyond emergency services, we're going to go ahead and look at those location capabilities, how they fit into the LBS architecture, and then provide tools for law enforcement to aid in their investigations. So from emergency services regulations perspective, there are several key objectives that the EU had for emergency services. Obviously, we're going to focus a little bit more on the first bullet about response times through accurate location data and modern communications. But it would be a little bit remiss of me to skip the other important objectives that they had. One being enhance accessibility for vulnerable populations or people with disabilities, right? This brought about applications like text to 112, RTT or real-time texting, so that a direct communication link could be set up with the PSAP or emergency services, and texts are transmitted in real time, so you could actually physically see the end user typing, and obviously that feedback loop gives both the PSAP and the end user a positive feeling that there is somebody on the line and communicating with them. Another objective was interoperability across the EU countries. So they wanted to ensure that that 112 call and access to emergency services was available around all member nations as individuals were traveling across the EU. And finally, increase public safety through timely public warnings during large-scale emergencies. So member states and telcos were required to put in alerting for large-scale emergencies to the public, which was supported by cell broadcast systems or other modern technologies such as SMS-based alerting, right? So pinpointed SMS-based alerting. Along with our discussion about location, obviously there is data that is shared about an individual's what is happening here? An individual's location, right? So the location data that is sent during an emergency call is solely to be used only for emergency purposes and no private purposes. And this keeps it in accordance with the GDPR. So then PSAPs and emergency services and everyone through that call flow has to have security in place, right? So the data is protected, right? The data is secure at rest. The data, there's TLS supported into the emergency service system, and that there is no exposure to that end user's data throughout the emergency call. So let's get into the details of what the regulation was put in place to support, right? And that was ensuring that emergency calls are routed properly and that the location data is accurately identified. So the mobile network operators are required to provide highly accurate call data for emergency calls. So the regulation mandated that the location data have minimum standards of supporting network-based type locations, triangulation, multilateration, and then handset-based or GPS Wi-Fi location. And that information could be transmitted to the PSAP quickly. So this led to the use of AML, or advanced mobile location, and network-based technologies that were heavily driven by standards so that can maximize the accuracy of the call routing and the location. So a little bit more about AML. So AML is on the device, right? It's on smartphones. It gets kicked off when an emergency telephone call is set up, and it will go ahead and ensure that the PSAP or the location is sent to the PSAP or the location platform also for call routing. It leverages satellite and Wi-Fi positioning, and it fits into the LBS architecture a little bit like this. So again, it's on Android and iOS, and as the emergency call is made, it will go ahead and kick off and activate GPS and Wi-Fi. It'll, get a GPS position. It'll go ahead and look to see all the Wi-Fi access points that it has available to it. Get a Wi-Fi location, bundle all that information up, and send it via SMS. Google itself has a platform called ELS, whereby it actually has an HTTPS endpoint that could be used. But that information is then transmitted into the carrier and exposed to the location platform. So the location platform can then take that information and use it to determine the PSAP to route the call and the location data to. And so there, as you're making this voice call, there's no impact to the emergency call itself. So this is all running in parallel with the emergency services call that we'll be talking about in the next couple of slides. So a little bit more about mobile location, right? So we have the device-based location. Now we're going to look at the network-based location. I think when everybody thinks about the network-based location, they think about it's really doesn't have that high level of accuracy. Historically, when we go back and look at the old algorithms, it's the device is attached to a cell tower, right? There's the cell sector. I'm going to take the centroid of the cell sector, and that will be the location that's presented to the PSAP. Well, there's been quite an evolution there as the 3GPP standards have started defining other types of positioning methods. And so now we've actually moved, we've kind of got a order of magnitude better level of location accuracy as we've moved into what we call high accuracy, whereby the location platforms can now not only take advantage of the cell that the device is attached to, right? It also can get signaling strength information from neighboring cells that the device is attached to, and then use that to get a very high level or level accuracy. And as the evolution of networks has come along from 2G, 3G, 4G, and now into 5G, and the density of those cells has increased, you can imagine that it's just getting tighter and tighter and tighter, so that the network-based location accuracy is quite has high quality and lends itself to improving accuracy for law enforcement. So from a emergency services perspective, right, how does network location fit into the call flow? So in parallel with the device coming up, AML going out and performing its calculations, the device will initiate what's called a network initiated location request, and the data will be collected by the LBS platform. So underneath, within the LBS platform, there's a GMLC, a Gateway Mobile Location Center, which is kind of the entry point into the LBS platform. And then there's an SMLC serving mobile location center, which is used, and in 5G, it's called the LMF, the location management function. And those two are where the secret sauce and the location algorithms are stored for performing the location. So all of the signaling measurements get sent to the SMLC and the LMF. The calculation is done of the location, and then the GMLC will then go ahead and forward the location information to the PSAP that it is determined would best support the location where the emergency has taken place. So at that point, the PSAP can then turn around and use the information that was passed, specifically the MISDN, and then go ahead and request from the LBS platform, from the GMLC, the location of the individual, so that they can constantly poll as emergency services are being dispatched, and continually get location. So emergency services calls do take advantage of AG and SS data, as the platform itself can provide assistance data to get a fast fix and get the highest accuracy location, where we'll be down in the 5 to 30 meter range. Okay, so now we've described emergency services, right? We've discussed AML, the device-based, and how it comes into the location platform and data is sent to the PSAP. We've discussed the network-based and how it comes into the platform and can be discussed. Now we're going to come back out and discuss law enforcement, right? What law enforcement agencies operate within, and their legal frameworks and regulatory requirements that govern their use, and then we'll pull back out and start looking at the location-based architecture and how it can support law enforcement. So we're just going to go through two of the standards that or regulatory standards that apply to law enforcement. The first is GDPR. So as GDPR applies to the processing of personal data by private entities and organizations, exceptions have been written into the GDPR that ensure that it serves public interest, national security, and generically law enforcement purposes, right? So these two articles within GDPR permit data processing if it's necessary for performance of a task carried out in the public interest or comply with legal obligation. And this includes processing by law enforcement agencies when they're acting under legal authority, such as executing a warrant. Furthermore, there's the Law Enforcement Directive, which complements GDPR. And it specifically governs the processing of personal data by competent authorities for criminal law enforcement purposes, right? So it aims to allow law enforcement to collect personal data, including location data, which is necessary to prevent, to investigate, to detect, or prosecute criminal offenses. So these regulations allow law enforcement access to location data. Again, they are responsible for securely managing that data also. So from a law enforcement perspective, how they interact with the LBS platform is they are doing what is called a mobile terminated location request. So what I described before with the emergency services was a network initiated location request. But in that flow, I mentioned there was a pull. This is the pull request, the mobile terminated location request. So it allows the law enforcement agencies a non-intrusive way to determine the device's location. The law enforcement agency would interact directly with the GMLC, which is going to orchestrate the call. It's going to utilize the SMLC and the LMF to locate the device on the network. And it generally does not use AGN or AGNSS generally is not used outside of emergency services because there's actual interaction with the device. So that's why it's so important as we're moving into the future that these higher accuracy network locations that are being or generated are available to law enforcement. So we've discussed the LBS platform, the MTLR location requests that law enforcement can make. So what can law enforcement use on top of that? What types of tools do they have available to them? So as you can imagine, law enforcement now can locate and track subjects of interest in real time and then put those positions on a map, right? So they can go out in real time to the LBS platform, get the location, plot it on a map. Now you can imagine the tooling is advanced enough to go ahead and serially go ahead and interact with the LBS platform to go ahead and then track the user as they're making movements. And now once you're able to track, it allows you to then another set of functionality that gets applied on top of it is a set of triggers, right? So you can draw a geofence around an area of interest, right? And as the suspect enters or exits the geofence, an alarm can go off, right? That can drive law enforcement to, take specific actions, right? And then record other types of information once they're in a area of interest. Another type of capability is not only is the proximity to other suspects. So you could have the target that you're searching for. You can also search for an accomplice or other suspect. And once they're within a certain distance and a time threshold, you can set off an alarm to know that these two are potentially meeting. What is the area they're in? What other types of information can you collect when you see that these two individuals have come in together? Then there's dwell time, right? So as we see targets go ahead and sit, is it a residence? Is it a workplace? Is it an area of interest, right, to the investigation? So those can be flagged, and that data is all being recorded in the background. And a more sophisticated type of trigger is SIM change. So if the target is going ahead and swapping SIMs, other types of integrations can happen within the telco to allow them to go ahead and see the SIM swap and then alarm on that type of that type of event. Now, once you've collected and done a track on an individual, then you can go back and replay it, right? So you can imagine that you get a warrant, you are able to go ahead and track an individual for a specific period of time. Then you can go back post track and do a historical analysis on their movement. see what they've done over the course of 24 hours, 48 hours, or a week. And then, kind of start looking at their movement and their pattern of life. And then they can make those, based on that type of data, that you can make inferences back to any would-be crime that they had, committed. Finally, it's with all this data being collected, these systems can generate reports. There can be extracts from the system that you can pull out a history of location targets. You can obviously filter down and query out specific time windows of interest. Again, you can pull out a complete history of target movements. And then also they can extract when all of the alarms went off, because obviously the time and a location being associated together has quite a bit of information, all of which that can be used as evidence, in a case, a prosecution case against a would-be suspect. So here's some useful references. Always when I discuss regulations with people, I always want to get a read of them and a link to where they are. So again, the European Electronic Communications Code is here. The Delegated Regulation for Emergency Services link provided a link for the Delegated Regulation for AML, the LAD or the Law Enforcement Directive, and a link to the GDPR exceptions. So again, today we've looked at how regulations have driven technologies in the device-based and network-based domains within LBS, and how law enforcement can come in and then use those platforms, right? So this all helps telcos, when they are, typically or get presented with a request for information on a specific user, right? They've already gone and done the heavy lifting of putting an LBS platform and doing a pretty large integration of the platform into their network. And now they have the capability to serve and protect and support the law enforcement community. So that's the end of my presentation. Annie, I'll hand it back over to you.
Interesting. Are there any big things coming down the line? Any big changes that you're aware of?
Yeah, so the big thing coming down the line for us is 5G and the 5G integration. There's other aspects to that with beamforming that help support getting location, vertical location, right? So we can get location in a building, right? And then we're also seeing stuff with respect to private networks, right? There's enterprise private networks and private networks that are being built out into, for example, multi-use buildings, where we're, seeing those types of build outs and interfaces being defined so that we can pull that information in the content and use it in the context of emergency services call, as well as a law enforcement call.
Okay, and I had a long chat with the CTO in Asia Pac a couple of weeks ago, and I thought what he said about 6G was really interesting. He said that he thought 5G was the last ubiquitous G.
Yeah.
That was quite a nice way of putting it. And that in future, 6G will be for specific purposes, like, industrial or whatever. And
Right.
yet that's still intriguing, because that doesn't rule out 6G being nationwide. For example, if it's used by train companies along the railways and lots of other industries that have national infrastructure. So I thought that's quite an interesting conundrum. It's not a ubiquitous G, but it might still be a national G. And
Right.
where the commercial and other interests might kind of intersect there, including, of course, for emergencies.
That's right. That's right.
Not
I
just
mean, as 6G comes out, right? I mean, you could probably see there's going to be applications even within hospitals, right? And like major infrastructure, right? We expect to see a whole nother set of standards, right? And will those get, applied to an LMF, the location management function, or will that be extended, right? And for us, it's another source of high accurate or accuracy location.
And the other thing is, we're in 2024 now, late 2024. I know telcos, telecoms have long horizons, so
Yes,
kind of will be on us before we know it, sort of thing, really, or at least in the working towards it, because we're looking at maybe 2030, 20 to 2033, maybe as when this really gets going. But who knows? Look at 5G.
right. Well,
Expectations
I
there.
I hate to
So, you know.
yeah, I hate to say it, but that's just around the corner, right?
Well, I know. I quite agree with you. It's like I have a theory that by the time you're 80, you just must get up and go to bed because time
Right.
speeds up.
Yeah.
Anyway, Simon, that was great. Thank you very much indeed for that. And you are our last speaker today. I hope to see you soon.
Okay.
So
All
for
right. I appreciate it. Thank you very much.